Hi kids, now we'll be going to screw gauge. We'll see how to read screw gauge. So generally screw gauge looks like this. So there will be something called main scale. You can see that 0 is like slightly visible. I mean there is no error here, so you can't see that line. I'll show you later, there will be line. And these are circular scale divisions. There are 100 circular scale divisions, 0, 5, 10. So like it will be in the round format, right? 95 and 99, and that's going to be 100. 100 circular scale divisions. Now they have given here 1 MSD is 0.5 mm. 1 MSD is called as pitch. The other way of saying it is when you move it. Okay, I have zoomed the same part. There is no error. If you see this line and this 0 are coinciding, the meaning is no error is there. Now if you want to put some object and if you want to measure the diameter, you will be loosening this. You will be loosening this way. So 0, after that 5 will come, then 10 will come, so you will be loosening this way. When you rotate this way, it will be loosening and you will be fitting some object here. Now you can see here. Now when I am rotating it by 29 circular scale divisions, when I rotated by 29 circular scale divisions, this line is slightly visible. Now when I am rotating it further, one more line came. So the distance between these two, this is called as main scale. The distance between these two is given as, it is called as generally pitch, unless until they say something. So pitch is 1 MSD here. Generally that's how it is, unless until they specifically mention the definition of pitch and main scale is different. So the distance between two consecutive lines on the main scale is 0.5 mm. They said we will be taking that as pitch for time being. So that's what they have given in the very first slide. 1 MSD is pitch, which is 0.5 mm. So when you rotate it by one full circle, now if you notice here, I started rotating 29 divisions, then I crossed 100 divisions. Then again, once 100 division is crossed, again 0 will come, again 5, 10 will come, again 28 is coming. By that time you can see one more line is coming. The other way of saying it is, when you rotate it by one full circular scale thing, that is 100 circular scale divisions. When you rotate by 100 circular scale divisions, this will be moving by one main scale division, which is 0.5 mm, or it will be moving by some distance, which is called as pitch. Pitch here is 0.5 mm. So for one full circle, it is rotating by 0.5 mm. One full circle consists of 100 circular scale divisions. So for 100 circular scale divisions, it is moving by 0.5 mm. If I rotate by only one circular scale division, it will move by 0.5 mm by 100. So that's the idea we should be knowing beforehand. For one full circle, that is for 100 circular scale divisions, it will move by 0.5 mm. So for one circular scale division, it will move by 0.5 by 100, which is 0.005 mm. So what is the least length we can measure here? That's like one circular scale division, that is 0.005 mm. This is going to be called as least count of this instrument. The least length which you can measure using this instrument is this much, so we call it as least count of this instrument, that is one circular scale division. Right, so we'll be utilizing this information. Now if you want to find the diameter of some object, what we'll be doing is we'll be putting it here. While putting it here, like we'll be rotating it, we'll put it here and we'll tighten it, so it's looking like this. And in this case we have already seen there is no error, so we don't have to bother. No. I need to figure out what is the diameter. Now if you see, I rotated one full circle, then this line started visible, coming into picture. I rotated one other full circular scale division, full circle, then this line will start appearing. I will be rotating one more time, then this will start appearing. I will rotate one more time, it will start appearing. Then I am rotating even further. How many? 50 circular scale divisions. So basically I have rotated 4 full cycles, that is 400 circular scale divisions and 50 circular scale divisions. So either you can call this diameter is 450 circular scale divisions, or you can go with 4 main scale divisions and 50 circular scale divisions. You can go by both ways. I am going with 4 main scale divisions and 50 circular scale divisions. Now each main scale division is 0.5 mm, so 4 main scale divisions. 4 main scale division is going to be 4 into 0.5 mm, which is 2 mm. I am not bothering about the significant figures because we know like its exact length, 2 mm. Now 50 circular scale divisions. One circular scale division is 0.005 mm, so 50 circular scale divisions will be this much. Now what is the diameter of this object? That is the total. 4 main scale divisions plus 50 circular scale divisions, this plus this, which is 2.250 mm. And note that I am writing it as 2.250 instead of 2.25 because we know the least count of this instrument is 0.005. So we can measure this, we have some information about this digit, right? So yeah, now if we put the same object, same diameter thing, which is this much, in some screw gauge which has error, I'll show you. Now this screw gauge has an error. Everything other stuff are same. Like one circular scale division is 0.005 mm. We are using the same instrument, but there is an error. When no object is placed here, this 0 and this line are not coinciding. If they are coinciding, the meaning is no error, but they are not coinciding, so there is an error. Now what is the error? If I want to put some object here, I need to loosening it. So when I start loosening it, when I rotate it by 5 circular scale divisions, this 0 will come into picture here. So basically, when I rotate 5 circular scale divisions, this 0 will be coming into picture here. The other way of saying it is, 5 circular scale divisions will be how much? This much. So if I put some object of diameter this much, what will happen? It will be showing this 0 and this 0 will be coinciding. But according to our knowledge, our previous knowledge, if it is perfect screw gauge and 0 and 0 are coinciding, the diameter of the object is 0. But is it 0 actually? No. We have put an object of this much diameter. So when it is showing 0, if you want to get the actual value, you need to add this much. So we'll say there is an error and we need to add this much value to get the right answer. So we call it as negative error and we should be adding some value to get the right answer. So we call this error is negative error and we will be adding this value to get the right answer. When it shows 0, the meaning is the diameter is not 0, but if you want to get the actual diameter, you should be adding this value. Negative error and we will be adding this value. Now we are putting the same object and we are measuring. Again it is showing 4 main scale divisions and 45 circular scale divisions. Now some people, what they see is it is starting at 95. If I want to get 45 circular scale divisions from 95, I need to rotate it by 5 plus 5 plus, so I need to rotate it by 50 circular scale divisions. So some people will see it like I have to rotate by 50 circular scale divisions, or if it is too much confusion, then we will go with the same method, 4 main scale divisions plus 4 main scale divisions, 1, 2, 3, 4, 4 main. If at all it is a perfect screw gauge, how we will be measuring the length, we will be seeing how many main scale divisions are there, which is 2 mm, how many circular scale divisions are there, 45, which is 45 circular scale divisions, 45 into 0.005, which is 0.225. Now this plus this has to give us the answer if it is a perfect screw gauge, that is 2.225 has to be the answer. But we know there is a error. When we put an object of 0.025, when we put an object of 0.025, it used to show 0 and we know there is an error, we should add 0.025 mm to get the right answer. So we are getting this as the answer if we assume it is a perfect screw gauge, but it has an error, so we need to add some value to get the right answer. It is a negative error, we will be adding the value to get the right answer. So right answer is this much, we already know. We are using the same piece whose diameter we have to find. So now we will see the other kind of error. If you notice the error here, 0 went down. In the earlier case 0 was up, now 0 went down. Now if I want to measure the length of the object, or if I want to measure the length of the object, I will be rotating it this way, so immediately 10 will be coming into picture. So basically if I don't put any object, it is going to show me the reading of 5 circular scale divisions. 5 circular scale divisions is this much. So when I put object of 0 diameter, it is showing this much. What does that mean? This is not the right value. If I want to get the right value, I have to subtract this much value. We call this kind of error is positive error and we have to subtract some value to get the right answer. We call it as positive error and we have to subtract this much value to get the right answer. Now again I am putting the same object here and it is showing 55 circular scale divisions. When if I assume it is a perfect screw gauge, then the answer is going to be 1, 2, 3, 4, 4 main scale divisions, which is this much, plus 55 circular scale divisions, which is this much. But I know that's not the right thing, because we have already seen when we put an object of 0 length, it was showing something. So we have to subtract some value. What is that value? We have already figured out, that is 5 circular scale divisions. So if we assume it is a perfect screw gauge, you will be getting the answer is this plus this, but you know you have to subtract something. When you subtract it, you will be getting this as the answer, and we already know this is the diameter, right? And note that this has some significance for us, right? Thank you.